Welcome to Ask and Learn.
A 100-watt light bulb has a resistance of about 12 ohms when cold, so that's 20 degrees Celsius, and 140 ohms when on, hot. Estimate the temperature of the filament when hot, assuming an average temperature coefficient of resistivity alpha equals 0.0045 per degree Celsius. So we are going to make an assumption here. So the assumption is that resistance changes linearly as with temperature, because that's what the book says. The textbook says this, and it is valid at lower temperatures. However, at the temperature that a light bulb runs at, I would very much argue that this is a very erroneous assumption, but we've got to run with it because that's what the textbook says. So the resistance is equal to a resistance at initial temperature, so R0, multiplied by 1 plus alpha, the coefficient, times the change in temperature, del T. We're going to quickly rearrange that because we need to find the temperature. So delta T is equal, so just quickly to write, delta T is equal to T minus T naught. And rearranging this, so dividing through by R0, subtracting 1, and dividing through by alpha, we get that, and substituting for this, we get that temperature is equal to the initial temperature plus 1 over alpha R over R0 minus 1. And we know from the question that T0 is equal to 20. Because we're adding and we don't need to multiply together temperatures, we can just work in degrees Celsius. We don't need to convert to Kelvin because the answer is also in degrees Celsius. So alpha is given in the question there. So we got alpha in the question. So alpha is given here. And R is given by 140. Ohms. And we have that R0 is equal to 12 ohms. And substituting those into a calculator, we get that T is equal to 2,390, which rounds to 2,400 degrees Celsius. Now, linear approximations for dependence on with temperature with respect to resistance only work at small temperature differences. I would argue that this is a very poor example of using a linear approximation in a physics problem. However, if that's what the textbook wants to argue, and / if you have this sort of question in an exam, just follow through with it as much as it's slightly painful because it's not really correct.